We've created an LED controller that allows the programmer to individually control the brightness of each of the 9 available LEDs in the ECE2031 system. The interaction with the peripheral works as follows. The device uses two device IDs for communication with ECE2031, one for selecting the LEDs and one for changing their brightnesses. Using the out instruction with device ID 20 hex and an accumulator value between 0 and 9 adds the corresponding LED to the selection buffer, and using the in instruction returns a bit mask representing the pattern of currently selected LEDs. There are three special values, -1, -2, and -3, which respectively select all LEDs, deselect all LEDs, and deselect all LEDs while also setting their brightness to 0 simultaneously. Now, using the out instruction with device ID 21 hex and an accumulator value between 0 and 255, sets the selected LED's brightness values to the value in the accumulator by adjusting their duty cycles in the PWM module, which controls the effective brightness of the LEDs. However, using the in instruction with device ID 21 has no effect at all. The programmer has no need to think about the nonlinear behavior of human brightness perception, as the peripheral uses a gamma correction algorithm before sending the LED's duty cycles through the PWM module. We made a simple demonstration of functionality using the DE10 standard board with an FPGA implementation of the ECE20 system. The program running on ECE20 is an idle state program with no user interaction. At reset, all 10 LEDs have their brightness go up from 0 to 255 at the same time, followed by each of them being turned off one by one. Then, as we can see, the program selects LEDs sequentially and goes through a brightness gradient before moving on to the next LED. This happens in a loop indefinitely, but this sort of functionality could easily be implemented in an interactive program while it waits for the user to do something.